All right, today we are rationalizing the denominator, which you may or may not have started learning in Algebra 1, because it's one of those things that sometimes it's in Algebra 1 and then they take it out and they put it in, and I don't keep up, so I don't know if it doesn't matter, but you at the very least started learning it in geometry, and then you did it in Algebra 2, and then also in Algebra 3 if you did it there, so definitely not brand new. The reason we call this rationalizing the denominator is because a square root is an irrational number, and to have proper form, it is illegal most of the time, not all the time, most of the time to have an irrational number in the denominator. So you're probably at this level would be told if you're supposed to rationalize it or not. But that means we need to get the square root out of the denominator. But we have to do it legally. We don't get to willy-nilly make up stuff. Okay, it's not that complicated. We just got to make sure that we follow some rules. Step number 1 is obviously realizing you need to, because in number 1 we have a square root in the denominator. What is something I can multiply the square root of 2 by to get rid of a square root? Square root of 2. Okay, so if I multiply this by a fraction with the square root of 2 in the denominator, I cannot change the value of my fraction. I'm just going to change the way it looks. So that's like 2/4 and 1/2. Same value, fractions look different, right? So I need to multiply this by a value of 1 to make my green fraction a value of 1. I put a square root of 2 in the numerator. Then I just multiply straight across, and in the numerator I get the square root of 2, and the denominator, what's the square root of 2 times the square root of 2? 2. Can I reduce those 2's? No. When you live inside the square root, you live in a different world than when you live outside the square root. Okay, so that is it. That is my answer. Okay, we good with that? All right, on number 2, what do you think we'd multiply by? Square root of 3. So this will be square root of 3 over the square root of 3. You multiply straight across. When you have a whole number times a square root, they just stick together like a variable. So that'll be 5 square roots of 3 over what? 3. And then we're done. Okay. Any questions at all? All right. If you have a square root that could, or a fraction, or anything that could possibly be simplified before you do that, you want to simplify first. So like 6 is not a prime number, but it's only 2 times 3, so I can't simplify the square root anyway. I have 2 square roots here. I really don't care about, the numerator can be as irrational as whatever. But I'm going to multiply by what? What do you think? Square root of 6. Good. Square root of 6 over the square root of 6. Now, when I multiply 2 square roots together, multiply, not add. When I multiply, I get to multiply what's underneath. What's 3 times 6? 18. So I get square root of 18 over 6. 18, definitely not a prime number. So I need to try to simplify that. I'm going to do it off to my little tree off to the side just because it's in the numerator. 18 can be 9 times 2. 9 can be 3 times 3. So then these 2 3's come out as a 3. This guy has to stay underneath the square root. And then 6 is still in the denominator. Okay? Everybody with me? Now, can I reduce this fraction? Yes, the 3 and the 6 both live outside, so that's totally fine to reduce that, and 3/6 is 1/2. So this reduces to the square root of 2 over 2, which is the same answer we got for number 1. So the question in number 1, the question in number 3, and the answer, they all have the same value. They just all look different. Okay. Everybody good with that so far? Okay. So remember, our focus is the denominator. But the only thing that bothers me is the square root that's in the denominator. So on number 4, there's a 3 there. The 3 is totally fine. So I don't have to multiply by 3 square roots of 5. If you do, it's not wrong. You're just going to have more numbers and more work to do, but it's not the end of the world, but I wouldn't suggest it. Instead, since the only square root in the denominator is 5, we're going to do square root of 5 over the square root of 5. Multiply straight across. What do I get in the numerator? Square root of 10. And then the denominator, what's the square root of 5 times the square root of 5? 5. And then I do 5 times 3 and get 15. Okay, 10 is not a prime number, but it's only 2 times 5, so can I simplify that square root? Nope. So this is it. Okay. Any questions at this point? Alrighty. Number 5. All right, can I simplify some stuff before I worry about the denominator? Like, what's the square root of 4? 2. So can't I just change the numerator to 2 times 2, which is just 4? So I have 4 over 3 square roots of 3. If you can simplify early on, it just makes it easier on you later. If you don't, then you just have more to simplify in the end. It's not the end of the world, okay? Now, what would I multiply by? Square root of 3 over the square root of 3. So that's going to give me 4 square roots of 3 over what? 9, because square root of 3 times the square root of 3 is 3, times 3 is 9. And then I can't reduce any of that stuff there. Any questions at all? All right. All right, when I look at number 6, 15 is not a prime number, but it's just 3 times 5, so there's nothing I can simplify there. So I'm going to multiply by square root of 15 over the square root of 15. So what do I get in the numerator? 4 times the square root of what? Not 17. Thank you for participating, but try again. 2 times 15. 30, thank you. Over 15. Yeah, we know. It's like I wasn't trying to be mean. Your epiphany of I added, we know. All right, 30. If I try to simplify that, that's just 3 times 10 and then 2 times 5. So I can't simplify it, but you need to at least try. I'm not saying you have to write it down. Even if you just think about the 3 numbers in your head and you know that you can't, that's okay. But always make sure that you have reduced everything you can. Okay? Any questions at all? We all good? All right. Flip it over then. Now, can I simplify anything on number 7 before I start worrying about rationalizing? Yes. Listen, the numerator is going to stay the numerator, 5x squared. The denominator, 4 is still out here. The 3 is going to have to stay underneath. Do any x's get to come out? Yes, how many? 1. And then do any y's get to come out? How many? 1. And then the square root, I know I still have a 3. Do I have any x's left? No. Do I have any y's left? How many? 1. God, y'all are so giggly. All right. Any questions about where any of that came from? That's just from our simplifying that we've been doing, right? So now, all I care about getting rid of is the square root. I have the square root of 3y. So this is the square root of 3y and the square root of 3y. Okay? So in the numerator, it just all gets stuck together. I get 5x squared times the square root of 3y. In the denominator, I have 4xy times, then that becomes 3y. If you skip this step and just kind of know what it is and multiply, it's not the end of the world, but that's where a lot of careless mistakes happen as well. Even before I multiply this, can I simplify something? And sometimes simplifying is easier before you multiply, especially if there was like a 3 up here. It just makes more sense. But I can cancel out one of these x's with this one right here, right? And that's really the only thing I can cancel out. So then that leaves me with 5x times the square root of 3y over And then 4 times 3 is 12. And then y times y is y squared. Do it a piece at a time. I know some of y'all, you prefer to write as little as possible. I don't know if you think you're saving space or lead or what, but that's where careless mistakes happen. So write the stuff out. Questions? All right. Can I simplify number 8 first? Yes, you can. All right, so the 5 is out here. Can I take any x's out? No. Can I take any y's out? Yes. How many? 2. So this is y squared. The 3 stays underneath, and so does the x, right? Everybody with me? So then I multiply by square root of 3x over the square root of 3x. That gives me 4 times the square root of 3x over 5y squared times 3x. Anything I can simplify before I clean up the denominator? No, right? There's nothing I can cancel out. So this just becomes 4 square roots of 3x over 15xy squared. If you put y squared times x, that is okay. The way you'll normally see things and kind of the proper way to do it is to kind of put them in alphabetical order, but it's not the end of the world. It's not wrong if they're mixed up. Okay. Any questions at all? We're all good? All right. Can I simplify 9 first? Yes. In the numerator, the square roots, the 2 has to stay underneath, but can the p come out? Yes. So I get p times the square root of 2 over the square root of 3p. I multiply by whatever square root is in the denominator. Right? So in the numerator, I'm going to get p times the square root of what? 6p, good, all over 3p. Can I reduce? Yes, the p's cancel out, and you get the square root of 6p over 3. Can I reduce the 6 and the 3? No, because they live in different worlds, and I cannot simplify the square root of 6, so it is what it is, right? Okay, everybody good? Any questions? Okay, on number 10, can I simplify first? Yes, I can simplify not only the n, but the 8. So if I'm going to do my tree above it, just so I don't have to rewrite stuff, 8 can be 4 and 2, and then can be 2 and 2. Right? So 2 2's come out as a regular 2. The n squared comes out as n. That guy stays underneath. And then that's all over square root of 10n. Any questions about where anything came from? All right, so then we rationalize. I'm going to multiply by the square root of 10n. So this is 2n times the square root of 20n, right? All over 10n. We all good so far? Let's worry about the fraction part first. These n's can cancel out, and the 2 and the 10 reduce, so I end up with the square root of 20n over what? 5. Okay. All right. Can I reduce the square root of 20? Or can I should at least try, right? So 20, 4 and 5. Okay, so 4 and 5. And then 4 is 2 and 2. So then these two 2's come out as a 2. The 5 stays underneath with the n. And then there's a 5 in the denominator. Yes? Did I do this wrong? Okay. Yep, that's totally fine. Yes, that'll work for everything. So this was her question. She did it, but she didn't reduce first. She just right here went ahead and rationalized, which is fine. So in the numerator, she ended up with the square root of 80, then simplified her square root, did it all correct, 100% fine. But sometimes that'll give you big numbers that are yucky to work with. So like I said, it works either way, whatever works for you. Okay, it's a good question. Anything else? Okay, perfect. Let's do 11. Can I simplify first? Yes, so this is 2 over r times the square root of 6. So what's the only thing I actually need to multiply by? Square root of 6. So multiply by the square root of 6 over the square root of 6. This will give me 2 square roots of 6 over 6r. Can I reduce this? Yes, because the 2 6 will reduce to 1/3. So this is the square root of 6 over 3r. What questions do you have? Yes. Like in front of the square root? Yeah. Yeah, if you put 1 in front of the square root or like a 1 in front of the x, it's not wrong. I'm pretty sure in Delta Math's okay with it. I don't think anybody would ever count it wrong. You'll just never really see it that way presented to you. But yeah, it's fine. Anything else? Good question. All right, so I want y'all to do 12. I'm going to do it as well, but I don't want you to look at mine until you're done because our steps might be different, but as long as we get the same answer in the end, we're okay. All right, so no cheating. Do your own thing, and then we'll check it. And after I finish, I'll come around if you're having any questions or anything. So when you're done, check your answer first before you check the steps. Because again, our steps might be a little bit different and that's okay. But if I'm wrong, also tell me. Okay, 36 going 8. Yes, but I have a feeling something else is. Did anybody else get what I got? Okay. Okay. I'm just double checking. I was like, whoop, whoop. Okay. So then that means that somewhere along the way, 8 times 9 is 72. That's okay. So you have 10 over 72. Oh, you should have 20 over 72. Where'd you get 20 from?
Oh, because I did 24 and I got.
See, just 1 2 comes out. It's 6 times 2 times the square root of 6. That's where. Yeah. Okay. And see, if and I'm not saying what you're doing is wrong, but if you had simplified earlier, then you wouldn't have had the big numbers to mess you up. All right. Any questions at all? And if you didn't get that, make sure you can figure out what went wrong where. Any questions where anything came from? We can do this. We're good? All right. Your assignment is in Delta Math. It all works today, so no excuses. Get started. Get it done.